Assalamualaikum and hi to everyone. Thank you for watching this video. So in this video, we'll discuss about the logical addressing. And under the logical addressing, we have two types of addressing. The first one, we have the IPv4, and the second one, we have the IPv6. So an IPv4 address is a 32-bit address that uniquely and universally define the connection of a device to the internet. So device is referred to the node or any hardware part like computer, router, server. Okay. So IPv4 is consists of 32-bit long. So that means 32-bit is the size of this IP version 4. The IP version 4 address are unique and universal, and the address space of IPv4 is 2 power of 32, so equivalent to 429,967 and 296. So this one address space is referred to the total numbers of addresses in IPv4. So IPv4 can be represented in the decimal notation and binary notation. So this example of how we represent the IPv4 in binary, and this one we represent the IPv4 in decimal or in dotted decimal notation. So example of IP address, we have 128.11.3.31. So when you convert this one into the binary number, 128 will be 10000000. 11, when you convert, it's become 00001011. 3, when you convert, it's become 6 of 0 followed by 11. And for 31, when you convert into the binary, 3 of 0 followed by 5 of 1. So this one in the binary, this one in the decimal. Okay, 32 bits is referred to number of this one in the binary. When you calculate, it's become 8, 8, 8, 8. So 8 times 4 equal to 32. So number of bits is equal to 32 bits. Okay, you should know how to change or convert from binary notation to the decimal notation. So example here, change the following IPv4 addresses from binary notation to the dotted decimal notation. So at this part, you need to know how to do the conversion based on numbering system. So we are given the binary and then convert into the decimal number. So replace each section, so each group of 8 bits into the decimal numbers, and then you will get the dotted decimal notation. Okay, for example, A, you have 10000001. So when you change this value into the decimal number, you will get 129. So this one is basically base 2 number. So you have 2 power of 0 times 1, 2 power of 1 times 0 times 0. So you have 0, 1, 2, 3, 4, 5, 6, 7. So 2 power of 7 equal to 128 plus 1 power of 0 times 1. So you will get 129. Okay, the same goes for the rest of the bits. Then after you change, you will get this value. Okay, the next part, change the following IPv4 addresses from dotted decimal to the binary notation. So the same things should be you need to do the same thing. You have the decimal numbers, so each part separated by the dotted change into 8 bits in the binary. So 111, when you change the 8 bit, you will get 0110111. Okay, so this number is decimal, so divide by 2 and then get the remainder. Then you will get the binary number, or you can use your calculator in order to do the conversion. Okay, next example, find the error, if any, in the following IPv4 addresses. So for A, you have 111.56.045.78. Okay, the error at this point. Okay, D must be no leading 0 when we want to put 4, 5. And it's just for the reminder, each of these dot, the maximum number is 255 and it cannot more than 255. Okay, the next for B, we have 221.34.7.8.20. So what are the error here? 1, 2, 3, 4, 5. It's more than 4 numbers. Should be only 4 dotted. Okay, for C, we have 75, 45, 301, and 14. So the error at this point, because it's bigger than 255. The maximum number only 255. And for D, we have 111.00.10.23.14.67. So the error at this point, we cannot mix decimal and binary number together. If we want to use binary notation, so all must be in binary notation. If we want to use the dotted decimal notation, so all must be in dotted decimal notation. In classful addressing, the address space is divided into 5 classes. So when we talk about IPv4, we have classes of the IP. So it being categorized as A, B, C, D, and E. 5 category of the addressing. And this one is classful addressing. So in binary notation, the first byte for class A will start at 0. For class B, start with 10. For class C, it will start at 110. For class D, it will start at 1110. And for class E, start with 1111. This one in the binary notation. In decimal notation, class E will start from 0 to 127. So it means if the IP address is 0.1.1.1, so it start at 0, so that's mean class A. If for class B, it will start at 1 to 8 until 191. Class C, 192 until 223. Class D, 224 until 239. And class E, 240 until 255. So this is how it being classified based on the number and the class. So you must look at the first byte of the addresses. Okay, for this example, find the class of each address. For A is one in the binary notation. Then look at the first byte. Okay. So the first bit at the first byte is 0. So this is class A addressing. For B, at the first byte, you have 110. So based on this one is class C. Okay, for C, we have 14. 14 is between 0 and 127. So it's class A. And D, you have 252. So 252 is in class C. Based on this one, 252 under this category, 110 under this category. So based on this part, you need to know and differentiate or identify the class of that address. So this table show you number of blocks and block size in classful IP address for version 4. For class A, number of block is equal to 128. Block size is 16777 to 16, and application is unicast. You still remember the unicast, multicast, broadcast. Okay, and then for class B, we have 16384 for the number of blocks and 536 block size used for the unicast. Block C, we have 2,097,152, and then block size we have 256, is one also for unicast. For class D and E, number of block is equal to 1. Number of block size is equal to 268,435,456. Class D for multicast, and class E for the reservation. So these are the categories of the class A, B, C, D, and E. Okay, in classful addressing, a large part of the available addresses were wasted because in certain organization they only use certain IP addresses, so the rest are wasted. So IP address in class A, B, and C is divided into the net ID and host ID. So the concept does not apply for the class D and E, only for class E, B, and C. Okay, this one for multicast, this one for reservation. So we just focus on the unicast application. So class E, the first byte is referred to the net ID. The rest byte is equal to host ID. For class B, the first 2 byte for the net ID and the last 2 byte for the host ID. For class C, the first 3 bytes for the net ID and the last byte for the host ID. Okay. This one is the mask. Although the length of the net ID and host ID in bin is predetermined, because we already know that net ID, first and second byte, the first 3 byte, okay? We also can use the mask or default mask, a 32-bit numbers made of contiguous ones followed by contiguous 0. So the mask help us to find the net ID and the host ID. So this table show the default mask for the classful addressing, class A, B, and C. So in binary, CIDR/add bit here. This one is 16 bit here, and this one is 24 bits here. So this one is net ID. This one is host ID, SID. So the in dotted decimal, the default mask for the class A is 255.0.0.0.0. For class B, 255.255.0.0, and for class C, 255.255.255.0. So this one in dotted decimal, this one in the binary, and this one for the CIDR. So 8, 16, and 24. So if an organization was granted a large block in class A, B, it could divide this addresses into several contiguous group and assign each group to smaller network. And this part we call as the subnet or subnetting. In supernetting, an organization can combine several class C blocks to create a larger range of addresses, and several networks are combined to create a super network or a supernet. That part is the supernetting. Subnet, we want to class subnet, we want to divide the addresses into several contiguous group and assign each group to smaller network. We want to make a smaller network, so we use the subnetting. If we want to create a large range of addresses, we can use the supernetting. Classful addressing, which is almost obsolete, so it's replaced with the classless addressing. When an entity, small or large, need to be connected to the internet, it is granted a block range of addresses. So because of the obsolete, so we replace it into the using the classless. So there is no class. Okay, example here. Okay, at this point, show a block of addresses in both binary and dotted decimal notation granted to a small business that need 16 addresses. So we can see that the restriction applied to this block only need 16 addresses. The addresses are contiguous, mean continuous. Let's say the address is 16.0.0.1. So the next address is 16.0.0.2. That is contiguous. And the number of addresses is power of 2, or 1, 2, 4, 8, 16. Must be power of 2. Example here, 16, so it's equal to 2 power of 4. 2 power of 1. 2 power of 0 equal to 1. 2 power of 1 equal to 2. 2 power of 2 equal to 4. 2 power of 3 equal to 8. 2 power of 4 equal to 16. Okay, the number must be power of 2. Number 3, the first address is divisible by 16. The first address, when converted to a decimal numbers, if for example we have 3,440, 387, 360, which when we divide it into 16, the result will be 215,024, 210. So that means the first address must be divide to the 16. Okay, a block of 16 addresses granted to small organization. We have the block here, block of address. This one is block of address in the decimal notation. This one block of address in the binary notation. So example, total of address equal to 16. So 32, the first address can be divided into 16. 32 divided by 16 equal to 2. It must be contiguous. 32, 33, 34 until 47. Okay, based on this one. Okay, contiguous. Address is power of 2. Number of address. So example, number of address 16. 16 is power of 2. Okay, the first address must be divisible by 16. So 32 can be divided to 16. So in IPv4 addressing, a block of address can be defined as x.y.z.t/n, in which x.y.z.t define one of the addresses and the /n define the mask, the CIDR. Okay, the first addresses in the block can be found by setting the rightmost 32 minus n bit to 0. Okay, this example will be continued on the next video. So for now, you should know that IP address is one of the way we can identify the device that connected to the internet. So its content of 32 bits. The total space of IPv4 is 2 power of 32. In IPv4, we have the classful addressing. So in classful address, we have class A, B, C, D, and E. And because of most of the numbers in the classful addressing are wasted, because certain organization only use certain addresses in their organization and obsolete. Because of the factor, a classless addressing has been implemented, has been introduced. And then you also should know about the net ID, host ID, how to identify type of the classes, the IPv4. You also should be able to represent the IPv4 in the dotted and in the binary notation. Subnetting in IP address v4 is used when you want to divide your organization into a small network, and supernetting is needed if you want to make a large range of a network. So that's all for this video. Thank you and assalamualaikum.